This video is on challenges in tidying data. It can be a challenge to get the climatic data organized and ready for analysis. We show 3 examples. The first is from the Agricultural Research Institute
R-Instat
in Niger. These data are already in the right shape. The first 3 columns make up the date and the climatic elements are in the remaining columns. These data look fine. The challenges are minor and only become apparent once the processing starts. The second example has a common initial shape. Here it is. These are data from Marupa in Mozambique. A row is a month, so the first row shows the data from January 1969. A column is a day of the month from 1st to 31st. When a day is missing or non-existent, it is coded dash dash. There are 3 different elements and they are on separate sheets. The challenge is to combine the 3 sheets and then to reshape the data so it looks like the R-Instat example. The third example is from Garua in Cameroon. The user assumed this would be simple because the data were already partially analyzed. They are just rainfall. Here, each column is for a month. Each year is in a separate sheet. Within a sheet, here, 2013, a row is a day of the month. What could be simpler? In addition, the bottom of each sheet has monthly summaries. When teaching on good use of a spreadsheet, we caution against mixing primary data with analysis. At least we have them separate somewhere in the workbook. However, that is not the case here. So, this is the third set of data to organize. We are very grateful to the providers of this data who have allowed them to be shared. Each example is in the R-Instat library, so it is easy to practice should you wish. Users sometimes begrudge the effort to tidy their data and it can take a long time. It is a vital first step and you may need to become a data detective. Now back to the first example. Here it is again. Here, row 5 in the Excel sheet is a small problem when importing to R-Instat. It would be good to import the names in row 4 but not the units from row 5. So, we have copied all the data into a second sheet called Sadore and swapped the order of rows 4 and 5. We have also added a new variable called station. This isn't needed here because the data are just from a single station. It does no harm. If there are multiple stations, then they go down, while multiple elements go across. It is sometimes useful, as here, to split the tidying tasks between Excel and R-Instat. In Excel, we have added a third sheet, so all the changes we make are recorded. Now into R-Instat. Locate the Excel file using the File Open from Library dialog. Here it is. The sheet with the data is called Sadore. The preview shown here indicates we should skip some rows, which we do. Now it looks better. The evaporation variable looks odd. It has a C after the name, which indicates it's a character variable and it should be a numeric column. Use climatic, tidy and examine, visualize data as shown to produce the following picture of the data. This shows the character variable we saw already and 2 further ones. It also indicates another oddity in that all the variables are missing at the end of the data. Now we know which variables to examine. These corrections are usually best made in the original file, so we usually return to the Excel version of the data. Here, we show how to correct in R-Instat in case that is what you prefer. These three character or text variables indicate that there are some non-numeric values in the data. Detect using climatic, tidy and examine non-numeric cases. Use the evaporation variable first. We see there is a single non-numeric value. Repeat with the second and third variables. They are called non-num2 and non-num3. Now, right-click and choose Filter. Define the filter by non-num1 is equals to true, and then add the condition for non-num2 and non-num3 and change the condition to OR to give all the four filtered values. Correct these values. Right-click and remove the filter. Now, view the data to see the problem at the end. There is no data in 2015. Filter for the year being 2015. And delete all this data. Now, right-click on the evaporation column and select Convert to Numeric. We do this for the additional two character columns. Now, use the Visualize dialog again and the data look better. We know a few months are still missing at the end of 2014. The three last variables are no longer needed, so they can be deleted. The next step is to produce a date variable. First, check on the month variable called MOA. Make it into a factor variable. Now, check that the year has only 12 months. Use the right-click and labels. Surprise, surprise! Here, the year has 14 months. Change the capital J in Janvier into lowercase and do the same with the capital F in Février. Now look again at the dialog. Thankfully, there are now just 12 months in the year. The months being in French makes the date variable slightly more difficult to produce. Make the MOA variable temporarily numeric. They now take the values 1 to 12. Use the climatic dates make date. Put the date variable at the start of the data frame. R-Instat has kept the names of the months, so now make the more variable into a factor again. Next, use the climatic, dates, fill date gaps dialog to check there are no gaps in the data. This does not run but gives an error. We did say there were some challenges. It says there are duplicate values in the data, which is a surprise. They need to be found. Fortunately, R-Instat can locate them. Use climatic, tidy and examine duplicates, and choose the date variable. Then filter on the resulting dup1 variable. There is just one duplicate day, 3rd July 2009. We need to see them in context to make the corrections. So, remove the filter and view this data. July 3rd is repeated and July 4th is missing. So, we assume the second occurrence of 3rd July should be made into a 4. Filter again and make the two corrections. This to both the date and the day. Now, the fill date gaps dialog is used again. It works and confirms the data are complete. There is nothing to infill. We already have the year, month, date variables, but the use date dialog adds a day of the year variable. Use the climatic define climatic data. The data are now ready for analysis. Save the file so these steps do not have to be repeated. The other examples are each in a supplementary video. They are more fun. Try them in either order, particularly if your data has a similar initial shape to one of them.